Welcome to EDU World Space.
So in this problem, we're asked to look at this beam that's resting on two supports here. These supports don't hold the beam down, so it can lift off of the supports. And what we're worried about is if this block here gets large enough or farther enough out away from the pivot point here, then it will be able to lift this block off this pivot, off the support, and we will no longer have equilibrium. So what we're asked for is the length, the maximum length that this block can be away from this pivot point. And so the mass of the beam we're considering, and it's going to be uniform, so the center of mass is halfway in from either side. That's 3 kilograms. Mass of this block over here is 5 kilograms. This block is 15 kilograms. The beam is 1 meter long, and the distance from the center of the mass of the beam to this point here is 0.3 meters. So if we take moments about this point, and then take away this support, and so what we're basically trying to do is balance this bar here. So we take away this support because there's going to be no reaction force here. So all the reaction forces we have, or the forces generating moments, then are the weight of each object here. And so this mass here has a moment arm of d plus L over 2. Here, the moment arm of the beam itself about this pivot is d, and then the moment arm here is x. And again, I'm taking counterclockwise to be positive. So we can see g drops out, and we can find a formula for x, given the weight of each mass and the weight of the beam and this distance d and the length of the beam. And if we plug in the values that we were given, it turns out that x can be no larger than 0.327 meters. So if we move this block any farther out than this amount, we will cause this block to lift up, and we will not have an equilibrium situation anymore.